Welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to be teaching you about ionic compounds. So let's just get started straight in with examples, and you'll learn how to do it through all these examples. Okay, so first we are going to start with tin 2 chloride. You're like, wow, just thrown right into this, right? Well, something important to notice is if you know where the transition metals are, they're kind of this big like rectangle in the middle. Then you are going to be like, okay, so what's the charge of these transition metals? And the assumption is to assume 2 unless told otherwise by these Roman numerals, or for silver, assume 1, which we'll get to later with silver. Okay, so we're told tin 2. Now, what does that 2 mean? Well, that means it's the charge. So everything to the left of this staircase has like plus, like it wants to lose electrons. Everything to the right of the staircase wants to gain electrons. So that'll mean to the left of the staircase is plus, like plus, yeah. To the right of the staircase is minus. So this tin, which is to the left of the staircase, it has 2 because it's transition metal. So we say that is 2 plus, right? It wants to lose 2 electrons. Then chloride. Well, that you're like, oh, I might know chlorine. What you do with these ionic compounds is you changed, like if you're using just an element on the end, because it'll be metal, non-metal is ionic. So you're going to change like chlorine will be chloride. You're going to add an ide. And oxygen will be oxide. Nitrogen will be nitride. Fluorine will be fluoride. So you're just taking off the ending and adding ide. So chlorine, if we look at our table, has a charge of 1 negative, like 1 minus, or minus 1. So what you're going to do is you could say, okay, how many chlorines do I need to match the charge of tin? Because you want the charge to be equal to 0. You want it to be stable. So you could just be like, well, I need 2 chlorines to get a tin, right? And that would be perfect. You would just say, okay, tin, the symbol is SN. You'd say SN, and then the symbol for chlorine is Cl, Cl2, because you need 2 chlorines. Or what you can do is you can cross. So you can say, okay, tin has 2, bring that down here to the chlorine, and the chlorine has 1, bring that over to the tin. And you don't mark the ones. But where that goes wrong is when you have like 2 plus and 2 minus and you cross, you'll get like SN2, like O2, right? And you're like, okay, that looks good. I crossed. But what you need to do is simplify the amount. So it's like the smallest ratio. So 2 to 2 is really a 1 to 1 ratio. Okay, now let's go. Sodium is a 1 plus, is the charge. And oxygen, oxide, is a 2 minus. So if we cross, we'll get Na, Na2, O. Then iron 3 nitride. Nitride is nitrogen. So iron 3, we're told that the charge is 3 plus. Then nitrogen is 3 minus. Here you'll see the mistake some people would make. They'd go, okay, Fe3, then N3. All right, you crossed. But what you need to do is simplify that 3 to 3 ratio down to a 1 to 1 ratio. Like if it's 2 to 4, do a 1 to 2 ratio. Just simplify the ratios to the smallest amount. So this will just be Fe N. All right, now chromium fluoride. You're like, okay, find the charge of chromium. We go to our table and it's a transition metal. It's smack dab in the middle of the transition metal section. So what do? Well, remember the rule, assume like the charge is 2 plus unless silver is 1 plus. So chromium, we're going to assume 2 plus because we're not told. So if you get any transition metal other than silver, you're going to assume that the charge is 2 plus. Then fluoride is fluorine, and we go over to our periodic table, and it is 1 minus. So we're going to say 1 minus, then you can just cross. You can say CrF 2. And boom, you got it. Now, silver sulfide. Silver, oh, it doesn't have a marking with it. What is it? It's transition metal. Is it 2? No, it's silver, which it's a 1. Just try to remember that. So silver is 1 plus, and sulfide is sulfur, which is 2 minus. So this will be Ag2S when you cross. Now, we are going to go from the formula to the name. So remember that you're going to mark, like on the nonmetals, the second one in the sequence, you're going to turn like the ending, like the ine, like fluorine, to fluoride. Okay, you're going to add that ide at the end. Now, we have Kf. So you're going to say, okay, if you've memorized these elements and their symbols, which you should have, K is potassium and F is fluoride. So we're just going to say, okay, potassium fluoride. Because you're like, okay, F is fluorine, make it ide, fluoride. Then we have zinc oxide. We have ZnO. So we're like, okay, Zn, are you just going to say zinc oxide? No. First, look where zinc is on the periodic table. It is a transition metal. It's very close to not being. Like, it's just on the edge of the rectangle. But it is a transition metal, so you have to have this little, like the little Roman numeral, or you could change some of them into like different names, like copper 1 is called cuprous, and copper 2 is called cupric. But yeah, I'm not going to do that. I'd rather just have the symbol there. It's way easier to remember, easier to understand. So this will be zinc, and then you're like, oh, shoot, now how do I find the charge of zinc? Well, oxygen has a charge of 2 negative, and there's only 1 zinc, meaning that it has to be 2. Or what you could do is like, oh, oxygen has charge of 2, put that over here on zinc, and then zinc has a charge of what? Put it on oxygen. And it's just like, they have the same charge. Is because there's only 1 of each. So zinc is 2, and then oxide. Now, Cu2S. What is Cu? Cu is copper. Copper is a transition metal again. So, what do we have to look at? Well, if we look at this equation and try to find the charge of copper, we see that there's 2 coppers for 1 sulfur. Now, what does that say? Well, sulfur has a charge of 2 negative. So if you need 2 coppers for 1 sulfur, then your charge of copper is 1, because 1 times 2 would be 2. So that would even it out. So you are going to say copper 1 sulfide. Now, on our last one, it is AlBr3. So, if we look at our table, Al is aluminum, and you're like, is this a transition metal? It's beneath the staircase. No, it's not. Because it's not in that rectangle in the middle, it's actually just a metal. So it is under a 3 plus column. So this aluminum is 3 plus. Then bromine is 1 minus. So we're just going to say, okay, that is aluminum bromide. There will be more videos posted on this, and I really hope this was helpful. Thank you for watching.